Hi guys, this is Suman and you are watching Eternal Physics. In this lecture, we will derive the expression for electric field due to an electric dipole. Let's get started. Consider an electric dipole of charges minus q and plus q, and separation between them is 2a, which is standard. Okay. Now, at a point P, which is r distance from the center O of the dipole, where we have to calculate electric field. So let's draw the dipole first. This is the equatorial line. This is point P where I have to derive the net electric field. So for net electric field we need distance from the point charge. So there are 2 point charge, so we have to calculate distance from this positive charge and this negative charge. This will be distance from negative charge and this will be distance from positive charge. So if O is the center, then R is the distance from O to P. Now this distance will be root under R square plus A square. A square because A is the separation. A is the separation. Total is 2A separation. And this will also be equal root under R square plus A square. Now if you look at the point P, electric field due to negative charge will be in this direction, and electric field due to positive charge will be in this direction, away from the center. So net electric field will be sum of these two vectors. Now if we draw a parallel line, distance from A to P and B to P are equal. So if this angle is theta, then with this will also be theta, and this will also be theta. This is because this equal because isosceles triangle, and this is equal because these are two parallel lines. And if this theta, then these all also be theta because of parallel lines. Now name E plus because of electric field due to positive charge, and E minus electric field due to negative charge. Then net field at P will be EP is equal to E plus vector plus E minus vector. Since the distance and the magnitude of charge are also same, so the magnitude of these two field vectors will be equal. So mod of E plus is equal to KQ upon root under R square plus A square whole square. This is because field due to point charge is KQ upon R square, where R is the distance. Here root under R square plus A square is the distance from that charge. So we taken root under R square plus A square whole square. Now take one symbol for these two equal magnitudes. So by resolving these two field vectors, we can write it as for E positive vector is equal to E cos theta minus I cap and plus E sin theta j cap. Why this is taken as minus I cap? Because if we resolve these vector into their component, then the cos theta will be along this line which is negative x-axis, so minus I cap, and E sin theta is along the positive y-axis, so E sin theta with j cap. Now if we resolve the electric field vector E minus, then it will be equal to E cos theta minus I cap plus E sin theta minus j cap. Why minus j cap? Why minus I cap? Because if we resolve the E negative vector, then E cos theta will be along negative x-axis, so minus I cap, and E sin theta will be along the negative y-axis, so minus j cap. So EP will be equal to E plus vector plus E minus vector. So E cos theta plus E cos theta minus I cap plus E sin theta minus E sin theta j cap. This will come out to be 0. Now EP will be equal to minus 2E cos theta I cap, and cos theta can be written as B by H. B is A and H is root under R square plus A square. So we can take cos theta is equal to A upon root under R square plus A square, and E will be equal to, as magnitude which we have already calculated, K Q upon root under R square plus A square and this whole square. Now by using this you can write EP will be equal to minus 2KQ upon root under R square plus A square whole square, and for cos theta multiply A upon root under R square plus A square. Arrange this, minus K into Q dot 2A upon, by arranging this you can write R square plus A square to the power 1/2 3/2. Okay. Also Q dot 2A is equal to P, which is dipole moment. So minus K P, this is I cap, which is for direction, I cap, this is for direction, upon R square plus A square whole to the power 3/2 I cap. Now EP vector can be written as minus KP vector upon R square to the power 3/2. Why? Because A is very small than R. So R square plus A square can be taken as R square. So this can be equal to an escapee vector upon R to the power 3. Hence, electric field at equatorial line will be equal to minus kp vector upon r cube. This is important derivation. This minus sign indicates that electric field is anti-parallel to the dipole moment. If we conclude, if this is minus charge and this is plus charge, dipole moment will be along p vector, and the electric field at any equatorial line, suppose that here electric field will be in this direction. Thank you for watching, guys. Hit the like button, subscribe the channel and share this video to your friends. If anyone want to join the personal coaching, I can provide him. My contact number is 77649083 and 88. You can WhatsApp me and join a group where we can discuss the problems and your doubts.